Hello everyone, welcome. I hope you are all well. My name is Riley and I'll be hosting this technical webinar for you today. Before we get started, I'd just like to run over a couple of things, just like you all to turn off your notifications and sound. And sorry, that includes you, Lucas. But everyone just go to your settings and go to the notifications settings drop down menu and just untick all of those boxes there. That'll just make sure you won't receive any sounds, pop-ups or notifications during this session, which can be a little bit disturbing when you're trying to watch a presentation. So today's technical topic is the energy transition and how will it evolve. So today's session is being presented by Dr. Lucas Scoofer, who's based over in Queensland. He's a lecturer with us at EIT and he's a specialist in power generation and energy at Rio Tinto. And just some common questions. So basically everyone that is registered for the webinar will receive a copy of the PDF slides and a link to the video recording via email, likely tomorrow. I'll send it out tomorrow. And just check your junk email folder as well in case you don't see it in your inbox. We also provide a certificate of attendance for these sessions. So if you would like a certificate of attendance for this session, you can request one via the form that is provided at the end of the webinar. So about EIT, so we're an engineering specialist education provider. We have many courses in engineering, ranging from short courses that we call professional certificate of competency courses. We have diplomas and advanced diplomas in the vet sector. We have undergraduate and graduate certificates, bachelor's and master's degrees, and a Doctor of Engineering. So those are our higher education courses. We have industry-oriented programs, so that means our courses are regularly updated to stay relevant with the industry and make sure that our students have the best graduate outcomes. We have our vocational programs and higher education degrees registered and accredited by the Australian government. We also have programs that are internationally recognised under the one of the 3 international engineering accords, so the Dublin, the Sydney and the Washington Accord. So there are a few courses that we have that are internationally recognised as well. We have industry experienced lecturers, so not only those who are involved in academia, but even Lucas himself, who's presenting for us today. So we have many lecturers that are currently working in the industry as engineers and can apply that experience to their teaching, which makes for a more valuable learning experience. We have unique delivery model, which includes live and interactive webinars, similar to what you are in today. However, these free webinars that we run are quite the sessions are quite large, so there's about 170 of you at the moment. However, our class sizes are not that big, so our real classes, if you're a student at EIT, are much smaller and they're more interactive. We have our expert lecturers that I mentioned, dedicated learning support for our students, and also state-of-the-art technologies such as hands-on workshops, remote laboratories, and simulation software. Okay, I'll now hand over to Lucas, who'll be presenting this technical webinar. He'll just briefly introduce himself and then go over the agenda for today's presentation. Thanks, Lucas.
Thank you, Riley. Comms check there is all good?
Yeah, all good.
That's
Can
great.
hear you loud and clear.
Yeah, that's great. Great. Thank you, Riley, for the introduction. Good morning, good afternoon, and good evening to everyone who's on this webinar for today. And as Riley said, I'm Lucas. So I've got a background from the military, power generation and academia, and currently I'm working full-time with Rio Tinto in a refinery in Eastern Australia. And previous to that, obviously I've done work in the military and within power stations and also University of Queensland. So look forward to a good discussion today, and hopefully we're nice and interactive. So we'll get into it. Next slide. So a bit of an agenda, a welcome introduction we've done. What I'll sort of cover is wherever we come from in the energy space. This is more about, I guess, the energy space and the climate space, obviously, per se, but the two have interlinks, as we know. So everyone's talking about the climate at the moment, and the energy transition, electrification are probably some things we've heard about. I'll talk a little bit of the history then with where we've come from, and then we're basically in the fourth energy transition at the moment, and where will we be maybe by 2050, in 28 years' time. I'll talk about power generation, which is sort of part, it is part of the energy sector because I've got most of my experience within that area. What might be the best solution? Is there one solution, full electrification? Maybe, maybe not. And then I'll wrap up with a conclusion, and we'll have a question and answer session, but I think we can also have chat questions. So I'll probably post a couple of questions as we go through the webinar too. Okay, what's our motivation? So if we go back roughly 110 years, I've got a bit of an arrow there in Pittsburgh in the United States. If we were burning coal at our factory, it was a sign of prosperity. We were making money. Okay, but obviously our motivation 110 years later is no, this is no good. Okay, so the motivation is, yeah, pollution. So, you know, you can see a whole bunch of pollution here, and I'll just circle that. It's the stuff we don't see, the carbon dioxide, for example, that is bad for the environment overall. Okay, and we also get things like nitrous oxide, NOx, sulfur oxides, and they contribute to sort of acid rain. And also, nitrous oxides are actually poisonous. So, apart from environmental damage, there's also human health issues there. And down here, you know, as we sow, so shall we reap. Again, there has been damage done to the environment, and I'm just talking about obviously air pollution. There's also land issues and water pollution issues. I won't go into those, but it's, you know, the environment's not just about the atmosphere. You know, we have to look after the holistic ecosystem, and the water and the land systems are also very important. And the energy system as a holistic thing globally is also tied up in part of that. What do we have here? A picture, Edison. So a bit of a quote there: the vast networks of electrification are the greatest engineering achievement of the 20th century, according to the United States National Academy of Engineering. Yes, it was a great achievement last century, but what would be our greatest achievement this century? Would that be full electrification? So if I just sort of highlight the word electrification there, will we see full electrification of the energy system globally? So that means no more gas barbecues, no more gas powered cars, aeroplanes will fly on electric motors or use hydrogen. Okay, I'll step back. Excuse me, we won't be using fossil fuels. We'll be using gas, possibly hydrogen, for generating power or for aircraft, or will we just go full electrification? Very interesting. So there's a whole suite of technologies available. Some are very mature, coal-fired power technologies. Aircraft engine gas turbines are very mature technologies now, but even things like solar panels, wind turbines are quite mature now. Things like nuclear power, for example, which is a bit of a controversial subject in some countries. I know in Australia there's an issue, I guess, there with nuclear power. The main thing is to note that even back in, say, what is we now, 2022, 1910 roughly, there was an electric vehicle back then. So if we think about the energy transition for small scale transportation, passenger vehicles, for example, the reason the internal combustion engine came into fruition was because the likes of Henry Ford, for example, they could mass produce it on a large scale. At the time, electric vehicles couldn't be, I guess, produced on a large scale as such. So that's why the internal combustion engine became the dominant technology. So when we think about things like energy transition, what technologies we have available, sometimes there's a dominant technology there, and it's not easy to obviously move that technology out. For example, coal-fired power generation. It's very dominant within a lot of electricity systems globally. It's been there for a long time, well established. The thing about the costs of getting rid of that and replacing it with a much cleaner source of power, for example. And speaking of power and energy, just a bit of a heads up here on units. So when we talk about power, we're talking about something measured in watts, for example. So a watt, a kilowatt, or a megawatt, which is 1,000 kilowatts. So that's just the power. So the power of a power station, the power generated by a car motor vehicle could be, say, 100 kilowatts. Okay. Energy is a different thing, and that's on a, for example, a watt hour or kilowatt hour in this example. So in Australia, we pay for electricity in cents per kilowatt hour. Right. So a kilowatt hour is the energy produced or consumed by either one kilowatt rated generator or energy consuming device that would run for an hour. So if we have, say, for example, I'll type it in here, we pay, say, 30 cents slash kilowatt hour, okay? And if I have 1 kilowatt times 1 hour, oops, times 24, we can, oh, sorry, my apologies, 1 hertz, not 1 hour. What are we paying for a whole day? So 30.3 times 24, about $7.20 for a particular device. And that could be a heater, for example. Okay, so we're probably paying $7.20 per day for a heater if we had it on a 1 kilowatt heater. An air conditioner, if it was 1 kilowatt, there's a lot of air conditioning systems that are more than that. So if you run them 24/7, you'll be paying a lot for electricity per day. Yeah, and that's an issue. So we take power off the grid, or do I have solar panels on our house? So this is all a part of our energy transition and thinking about, do we still take electricity from the grid? I'd like to ask everyone there a question. Are there any suggestions on what you think the energy transition means? And if you just pop some thoughts into the chat, that would be great, please. I haven't got any. Yeah, I mean, if anyone wants to type something, that'd be great. You know, there are formal definitions available, but you know, there's quite a few of those. But I'd like to, you know, just keep typing in. That'd be really good, and I'll just sort of move to the next. But yeah, I love it. Yeah, that's great. Everyone, so you're coming in now. So beautiful. That's really good. I love it. So yeah, keep pushing those out. That'd be great. And what I'll do now is I'll move to the next slide. Oh, by the way, this one here, I've got a lot of books. So this one here is a pretty good book by author Vincent Pete, and he speaks about the age of fire is over. So basically, fossil fuels are over. So yeah, keep coming those in. They're great. So what we'll do now is have a few examples here. And again, there are many definitions for energy transition. So especially from journal articles and proper books in the area. So one would be the change in composition or structure of the primary energy supply. Doesn't talk about demand there. The next one is talking about the energy system undergoes a change, in particular for greenhouse gas emissions attributable to the energy sector, which are quite large. And the last one is a fundamental structural change of the industry. So the last one here, it sort of includes supply. So this word here, supply, it's not only supply, it's also demand. So I would say the energy transition includes a structural change. So we've got a certain amount of quality and quantity of energy being supplied. But there's also the demand of energy from, for example, we're using laptops, mobile phones or whatever at the moment. So obviously we're consuming electricity, how are we consuming that, and how we can do that in a cleaner way, right? Reference here, so I've got a reference list at the end of the slideshow, and as Riley said, he'll punch out the slides or something next day or two. So there's quite a lot of good books. The thing is, obviously, with this, I'm only giving you a very small coverage of what energy transition is. There's such a huge area now. There's so much information out there. So it's good to sort of condense it into a really specific area. I see someone's mentioned hydrogen there. We're looking at hydrogen in Australia for power generation, for example, and having a hydrogen hub in various regional areas within the country. So, you know, some people focus on electrification, some focus on hydrogen, some focus on a thing called carbon capture and storage. Another one I see there, renewable energy, geothermal. That's really great, everyone. Others talk about nuclear, which is, you know, that can be quite an emotive subject. And I'm not here to promote any form of power generation. I'm here to promote that we should do something for the planet, okay, in the energy space. So if we think about having a sustainable future, energy transitions are actually, like I mentioned before, they're not a new thing, and there are past, current, and upcoming ones. All right, so we've got a current one, maybe the fourth. Is there a fifth energy transition after that? And generally, these may take, say, 50 to 75, that should be years for the new technology to become dominant. Okay, so for example, we've gone from wood to coal, coal to oil, oil to gas, gas to, say, renewable energy as sort of a transition. It's taken roughly 50 to 75 years for the new technology, for example, coal-fired power to take hold within the electricity generation. Now, do we have that amount of time for this current transition? Okay, so that's the main thing, guys. And when I talk about this, I'll talk about, I'm an engineer, but I know it's not just about engineering, it's about economics, finance. I've got this below here. So engineers, we may be sort of honed in on engineering, but no, there are environmental pressures. And I spoke about, obviously, for the air, which sort of concentrating here at the moment, greenhouse gas emissions, but also the water and the land. There are economic and financing issues, if government policy settings. So government should not tell us sort of what technologies we should sort of go for, whether it's nuclear, electrification, hydrogen, and so on. Government should set the policy settings. So, for example, a private business would come up with the best solution. Obviously, you know, money comes into it. So there's a good balance between, you know, going for the best available technology and how much may it cost and what the future holds too. There's also legal issues involved with all of this. There's a whole body of work within. There's a thing called, I'm not sure if you heard, the just energy transition. Okay, so talking a lot about here about reducing emissions and stuff, but a just energy transition means that it's great for everyone. Okay, so it's not just one particular group of people or a group of, you know, multinational corporations makes good money from it and everyone else suffers. So there's also, and that sort of links between the legal and ethical space and moral space, I would say. So there's a thing called the just energy transition. I'll just can type that in here. So the just energy transition is very important. And lastly, innovation has obviously a big part of this. On the supply side, so technologies for supplying energy, whatever they may be, but also technologies for consuming energy, yeah, and making the energy consumption more efficient. So if you've done subject in thermodynamics, you would have learned about the first and second law of thermodynamics. If you can come up with a way of negating the losses, the huge losses we may get in a system from the second law of thermodynamics, we may lose possibly 35, 40% of the energy in a, say, coal-fired power plant or combined cycle gas turbine power plant. If we can utilize that energy, then, you know, that's a great innovation, for example. So when I speak about innovation, there's a whole bunch of technologies that are available now. I can't tell you what would be available in the future. Okay, it'd be great if we could predict what might be available in 50 years' time or even 30 years' time, but it's really good that innovation is there too. And the innovation is fostered by all of the above elements in a way. Just on the right here, I've got a screenshot within the state I live of Queensland in Australia. Governments now, this is a government departments looking at a hydrogen safety code of practice, for example. So as we transition, there's things of, for example, asset management and asset integrity and also process safety management, which come into play with new technologies, for example, everyone. Bit of the terminology here. So I'll just get my little pen out. So the first line here, I've got climate is a big, and I've put big in big letters because, yeah, it is a big motivator for a sustainable future. Okay, and obviously the IPCC, the Intergovernmental Panel on Climate Change, They've released their 6th assessment report last year, and there's updates on that all the time. So, you know, that is around a few thousand pages of text. Now, there is a energy section within that, but if you're interested, obviously just download that from the IPCC website. So, okay, a couple of definitions. A zero carbon energy system is actually, there are no human related emissions. Some people think zero carbon and net zero are the same, but they're actually not. So in a net zero carbon energy system, we'll still have some emissions, but they'll cancel out by some mechanism. They may absorb carbon. That could be CCS, carbon capture and storage, should I say, and possibly sequestration using trees. Okay, so some people look at planting a whole bunch of trees where trees have been knocked down, for example. Now, decarbonisation, so emissions must go down faster than anticipated, and IPCC and a few other government bodies and think tanks have actually said, yes, we should be doing this. Okay, so globally, some companies are looking at net zero by 2050. Okay, so, you know, is net zero, what I'll do, I'll actually ask is, I'm just typing in a question I'm going to put up. All right, so I'm going to post that. Hopefully that works. I'm asking a poll. So there we go. So I've posted a poll, everyone. So is net zero possible 2050? It'd be just cool to see what you think. Can we push emissions down faster? My view is that we cannot achieve by, so I'm talking about energy efficiency and decarbonisation. Energy efficiency is another, so that's just being more efficient. So in terms of how much output we get for an input, if we have more efficiency, we get more output for a certain given level of input, right? We can't achieve net zero by energy efficiency measures alone. So that's a really interesting point. I'm getting some good responses here. We've had around 140, so it's around 55 said yes and 35 have said no. So at the moment, most people are saying that, yeah, net zero is possible by 2050. And whether you're an engineer or economist or policy person, we all have to work together in this, or innovator. Okay, so it looks like the yes is around, you know, 2/3 of the response for positive there. Okay, so where have we come from? Like I said, they're not new. So I've already spoken about energy transitions are actually not new. If we go back around 250 years, or, you know, to the 18th century to 1780s, for example, wood was being burned, especially in the UK. So in the UK, coal became a dominant technology. Then around 1860s, 1870s, oil came into play. So in Pennsylvania, oil was discovered, so oil took off. So we had a sort of a combination of coal and oil. Interesting to note that UK is probably the only country in the world that's been burning coal the longest, and that's been around 250 odd years. So we've sort of transitioned away from these very carbon heavily intensive emission fuels, coal and oil, to a fossil fuel. Gas is still a fossil fuel, but it has much lower emissions per unit of energy, for example. And now we're sort of going on the renewable sector now. And next one is sort of the electrification. So renewables actually been around a long time. In Australia here, for example, in my state, we'll probably have during the middle of the day around 35, possibly 40% of the grid is from renewable energy, mainly rooftop solar on houses. Okay, so renewables are coming into play. They're actually much cheaper now in terms of dollars. So if I put a sort of draw a dollar sign there, they're cheaper than coal, oil, or gas. And if you've been following coal and oil and gas prices, they've gone up this way this year. So it's interesting because of geopolitical forces. And that's another issue. There's a whole bunch of geopolitical issues and forces that are driving all of this. Now, these previous transitions, if we look back to, say, number 1 and 2, obviously technology had an issue. Economics had to be an economically and financially sound. The environmental transition, even from, say, wood to coal in the 17th and 18th century, that was driven by environmental considerations that people were burning wood inside of their homes, generate a lot of nasty dust, particulates. So burning coal is even better, but then even burning coal is not good. So we can move away from wood and coal and burn, for example, gas. But after a while, we can electrify everything in the house. And back then, there was ease and convenience. For example, wood was available everywhere. Coal, we started digging that up, whether open cut or underground coal mines. And oil initially was easy to find. Obviously, Saudi Arabia, biggest oil fields in the world, around 25% if I remember. But now the US is actually a large supply of oil too. But the extraction technology and actually refining technology is well developed. So it's a mature technology. Costs have come down, but there are geopolitical pressures now that are raising prices again. But now the current transitions, we know that politics and policy are very important. So the IPCC, governments now are supporting transition to net zero. Big companies are doing that, and the policy setting is there. But there's been a rise in activism too, and the people are speaking out, and that's really good to see. The citizens are speaking. What have I got here? Second last point, consumption again. Whatever I'm consuming power at the moment at my home here, the lights are on. It's almost, it was 5:30 p.m. in the afternoon. It's getting dark because we're in the winter period almost. So I'm consuming electricity here, obviously, and that contributes to greenhouse gas emissions. If I had a heater on or air conditioning on, that's not really good. So again, energy efficiency in devices is important. So which I've got as the last point. Now, I'm not going to go into detail too much about this, but if we go back to 1896, Hennius, I think I've pronounced that properly, looked at the influence of carbonic acid in the air upon the temperature of the ground. So this is basically like one of the first, probably the first journal article on emissions affecting the atmosphere. Okay, so it's a long time ago, isn't it? And you can actually download that off the internet. Just sort of do a Google search, and you can find that journal article. Right, and that's 1896, which is quite a while ago, isn't it, everyone? Okay, so which countries emit the most? Now, I'm not here to shame anyone. Sorry, I'm just, it's just interesting. Let me get a blue pen out here. So where are we? Australia, New Zealand. So Australia, New Zealand, we're one of the highest emitters. This is per capita or per person by country. And again, the reference is down there from the IEA, International Energy Agency. If you want to look this up, or just even Google, so other countries there, United States is pretty high too, and down and down. And you can see the most populous country in the world, China, is actually not as bad if you want to, from a per capita emissions. Again, this is just the way it is. I'm not saying so. US and China are probably the largest emitters by absolute value, but the per capita is quite different. Okay. And as it goes around the circle there. So it's very interesting to see per capita versus absolute emissions. Now, I've spoken about energy transition. There's another concept you may have heard of called the circular economy. And that's a very interesting concept, and it all sort of ties in with energy use, the emissions around the globe, and so on. So in the economy, we use, so a circular economy means that we'll reuse a product. Okay, we may recycle a product, we make a product into something else at the end of its life. So basically, don't go into landfill. Okay, so yeah, that's not a couple of cartoons here just for a bit of a lightheartedness. But yeah, we should not just throw stuff back into a quarry, for example. And there's another thing here, or extend the life of an asset. Okay, that's an interesting point here. When I was doing my research at the uni in power generation, it was interesting to see nuclear power plants. So obviously they're over designed. Okay, there's a lot of safety inbuilt into a nuclear power plant. And I was sort of designed maybe for a 40-year life, but there is work going on to extend the life of those to say 80 or 100 years. So basically what you're doing, you're getting more out of that asset, for example, okay? And the same thing for power plant or your car or your mobile phone or so on. Should I keep it or should I replace it every 2 years? Or should I and I know in Australia we can actually recycle mobile phones, for example, and I think even remake, or they break them up and get the components out of it, and they can use it for another process. Okay. And if you're an engineer, additive versus subtractive manufacturing. So I've been brought up on a subtractive manufacturing. I'll turn something down on the lathe, and all that metal is now thrown away. But if we have 3D printing, for example, additive manufacturing, we may not use as much iron ore and coal, for example, to make steel. And there's even green ways to make steel. So when we think about sustainability, we think about everything in the value chain, from the raw product, comes out of the ground, to the final product, our mobile phones, and how we may reuse it. Don't dispose of it in land, right? That's not good. See if there's another way to use it, and that will help us in the energy transition, but also climate change overall, and the land and the water pollution too. Okay, how much energy do we need? So depending on which source you look at, the sun provides a heap of energy to the earth, around 430 exajoules per hour. Now, the second point there, this energy is approximately what all humans on earth consume in 1 year. Okay, but it's not that simple. So a lot of I'll just draw sun, all the rays come in, the energy is coming in, but our atmosphere will actually reflect back about 2/3 of that, but we still have 1/3 of that available. So what's 1/3 of 420, 140, so around 140 exakilojoules. So maybe we can capture something over the period of 3 hours, and then we've got all the energy we need for a year. Again, it's not that simple, is it, everyone? Solar panels are great, but also because of the sun, we have wind and so on. So we can have wind turbines, but then we need battery storage. So you can see I start talking, I can capture this, then I've got to capture with solar. Maybe I can capture with wind, then I can store it in a battery. But then how do I release it for energy consumption later? So there's a whole bunch of issues here we've got to think about. It's not as simple as it seems. What can we do as consumers? This is taken from an Australian government website, yourhome.gov.au. You can look that up if you like. The traditional meter we have here in Australia spins round and round and round, but now we have things like smart meters. What a smart meter does is, I know at this time of the day, the power price is very expensive, so I'm not going to run my air conditioner now, even though it's 40 degrees C. I think I might run it though, because I need some comfort. So again, it helps you make a decision. Should I actually turn on this electricity guzzling, will I call it that, device, an air conditioner, which is say 5 kilowatts. And if I run that for a few hours, it's going to cost a lot of money. And also the electricity grid is going to suffer because everyone's demanding it. Let's have another look at incandescent versus LEDs. So incandescent, I'll put a big cross. I don't like those anymore. Always go for LEDs, guys. Over the period of, initially you're going to pay a lot more for an LED. So this is from a British reference, but in Australia we'll pay a bit more, but over the long run, definitely much better and more reliable too, and a longer life. Now, this is just for illustrative purposes, and there's a reference there from a company called Rystad. Okay, so it's taken from a company called Rystad Energy. You can see the global energy system is quite complex. So basically we have our primary energy inputs here, a bit of refining, we make electricity, and then we distribute it and store it, for example. And there's a whole bunch of end use here for a building, whether like cooking or cleaning, if I'm going on a train for rail, in industry, and so on. Okay, I've spoken about sort of us domestic consumers. There's also commercial, mining, and like I work at a refinery, so we're a huge user of energy. Okay, guys, so yeah, we have to look at how do we get more efficient, but also decarbonize. So as you can see, the energy system globally is very complex. Yeah. And again, I said, look at the primary energy sources here on the left column, or the left bars, for example. There's a whole bunch of technologies there. Which one is the best? Yeah. Again, coal is sort of going out. Oil will go out. Natural gas is not having a good time. Methane emissions are no good. So these are the baddies at the moment. Nuclear, I'll draw a bit of a question mark there. These, obviously thermal, a bit of a question mark there. It's available, but not easy to get. But, obviously these ones here, solar and wind, bit of a tick, and hydro too. But hydro is a problem. Australia's a bit of a dry continent. We've had a bit of rain lately, but do we always have water available for that? And there's a whole bunch of stuff on the right here. Again, food and land, agriculture. Okay, so as you can see, the global energy system is not as simple as make some electricity and I'll pump it through the system, and we have an output for boiling water, cooking, and so on. Okay, just a bit of a coverage on life cycle costs from engineering point of view. So again, looking at the total cost of an asset, and I'll just bring up an example soon, and that's through the planning, design, acquisition, construction, acquisition, operation, and disposal, okay, or maybe reuse. Okay, so this quote's from a few years ago. Maybe we don't say disposal anymore, we may say reuse. I found this example pretty cool from Amsterdam. I've never been there. It's a bit of a long way from Australia, but it'd be cool to visit if I could one day, or a similar building in Australia. It's a 15-story building for a consulting firm. Now, the consulting firm has actually 2,500 employees that could work in this building, yet there's only 1,000 desks. And they have a smartphone app, and that connects every employee. And if I want to go into work tomorrow, I'll say I want to go into work from 8 till 12, and it'll actually tell me where I should sit. So it may say to me, Lucas, you sit in this little office here. For example, I'll put the red, okay? 25% of this is dedicated to meetings, and it's entirely renewable, and its energy consumption is very low. It is, I want to point out, it's very low energy consumption, and it is a new building. However, you may say, oh, that's great for new buildings. How about existing stock? And there's obviously a whole bunch of existing stock, building stock globally. Yes, that can be modified. And what we need to do is really optimize our space and energy use. But just think about your own building. If you're in an office building, do I need to be there? Can I work from home sometimes? If I go in, we use an app so we can organize our meetings and stuff? So that's a really good example of a new building, but existing buildings can be remodified for optimizing the space and energy use. Life cycle costs, the main thing is there's a whole list here. The environmental targets I've got up the top. Obviously, capital costs and depreciation from a financial view, there's always that aspects. But then once we have something in place, we actually have to operate and maintain it and renew it. So once you have a new technology come in, it's not just about, I'll spend $500 million on a new power station. Then I've got to operate, maintain it, renew it every now and again. If we get loss of production, then that could be an impact. And loss of reputation, these are some things that, for example, environmental damage. There's been, a few companies, if we think back to 2010 for Deepwater with BP, if there's a movie on Netflix, Deepwater Horizon, interesting movie. As an engineer, it's fascinating to watch, okay? So again, environmental damage can lead to loss of reputation. And when we decommission, dispose, again, disposal, do we do something with it? And from a finance view, everyone looks at the time value of money. So I guess money comes into it, okay? So we can't get away from it. Okay, let's have a look at existing power generation technologies, and I'll use examples within my country, Australia. So within Australia, on the eastern seaboard and eastern south and sort of central seaboard, from Port Douglas in northern Australia to Port Lincoln in South Australia, it's around a 5,000 kilometre transmission line, all right? And there's a subsea link to the island of Tasmania, okay? The balancing of the system is very tight, and it's run by a market operator. Some of the challenges are there was a turbine generator set that blew up last year, as you can see there, and this is a piece of the shaft between the turbine and generator. Luckily, no one was injured or worse, but that's caused $200 million of damage, and it's offline for 18 months. And this is a coal-fired power station. And when that went off, the power prices went crazy. All right, so there are challenges now with aging, for example, coal-fired technologies. How do we replace those with wind or solar? Now, let's have a look at in the state of Queensland here, and there's a reference there if you need to. So I've just taken a snapshot from the 23rd of May, so earlier this week, during the middle of the day around 11:30 a.m. And as you can see, it's got renewables there, so it might be a bit hazy. 37.5% of our power generated in our state was renewables. This black stuff is coal, and that's around, if I can read, 55%. about 10, 15 years ago, coal in this state was 80, 90% of the generation, and hydro, we got a bit of hydro, so that was also in gas. But now coal is definitely going down, whereas renewables, rooftop, utility, and wind, for example, these three up the top are really coming into play. But that's during the middle of the day, as you can see here, everyone. So during the middle of the day, the yellow stuff up there is the renewable stuff. But at night, so this is at night, there's nothing obviously for solar anyway. There might be a bit of wind. So the challenge is, again, how do we have batteries come into play and discharge amount of power for overnight use? Now, over the whole life cycle of any energy asset, it's not just power stations. What do we want from that asset? What do we want from our demand devices? We want to have affordable cost. Yep. So it's got to be affordable. We want to have electricity, for example, available 24/7, and it has to meet every time I switch something on, it has to be there. And zero or low carbon energy obviously now has really come into place. Yeah. But within the state of Queensland here in Australia, electricity is actually classed as an essential service. All right. So there is legislation in place that electricity has to be supplied. And I'm not sure what happens in other jurisdictions, but I know that, we have it on 24/7. We have the loss of power even every now and again, and people go sort of crazy when it does go off for an hour or two. Can we sort of reconcile this simultaneously? And North of Michael Pollitt from the UK spoke about this 8 years ago. So again, we've got all these three levers pulling on each other. We try to reconcile those all together. Okay, this is an interesting one I discovered quite a few years ago. It's a bit dated maybe, but I don't think the jury's out on climate change. We know climate change is real, but if we look at nuclear, some people don't like it. Oil we don't like because of BP. Coal I don't like, but also I don't even like wind. Okay, so in Australia, wind farm was offered to a community in the southern part of Western Australia, and actually rejected it because they said, we don't want wind turbines, they're too noisy. So it was interesting. This was about 10 years ago, guys. So they said, no, I don't want wind power in our backyard. We want something else. Give us another sort of power supply arrangement or deal. So that was very interesting. So everyone has their view. What I'd like to do now is, again, a bit of again on the chat, please, if you don't mind, your view of the energy future. Again, I'll keep talking, keep gagging because I've got to finish up. But there are some solutions. NIMBY, not in my backyard. Nope, not on planet Earth. So there are some people with that view. Oh, if we're going to bet on the energy futures, would solar be 3-1? Would nuclear be evens, and so on? Note down here, guys, in the bottom left corner, this is a solution, and this is from 2009. A person using a solar cooker to prepare a meal. Okay, how much do you think that dish cost, that parabolic dish in US dollars? Any guesses? So while you're typing in your view of the future, also sort of give us a guess of how much that might have cost. Oh, good. There's some coming in. That's great. I love it. You'll be surprised how cheap it was, actually. This is a nice solution, isn't it? Because I'm in a place where electricity is available 24/7, 365, but a lot of the world doesn't have access to 24/7, 365 electricity. So we have to find solutions, not just for, again, that's the energy justice, or just energy transition argument coming here. Okay, there's some good ones coming in. Thank you very much, everyone. It was 10 US dollars I've seen. Yep, that was actually $10 US that cost. So it's a nice, really cheap solution, given, excuse me, given, the economics always comes into play too. Is it affordable? Can I, use that? Do I have to pay for a year's worth of wages for the electricity or the power supply? Decarbonisation. How much time have I got left, Riley?
We've got about 16 minutes left,
Okay.
Lucas, and we'll try and do a short
question and answer.
short Q&A at the end. But
Okay.
if it's not a big deal how much
No.
time we go
Yeah.
under or over, it's not a big deal.
Okay, that's fine, mate. I just wanted to gauge. I should be fine then. Thank you. Cheers. So I'm going to look at power generation and specifically a thing called the gas turbine, which is a more recent source of power. So there's been some talk about 100% hydrogen, carbon capture. Some people in Australia are quite cynical about carbon capture. And this is a journal article, and that's from 2005. So when you hear about hydrogen, decarbonisation, those words have actually been around, not just around 2018 and beyond. They've been around since the 2000s, if not before that. So when we look at hydrogen, a quick poll again. I should type this in, what I'll do. I've got to do it on the fly or at the same time. So I'll just type this in, everyone, and then I'll put it up, hydrogen. Okay, I'll start that. So the reason is I can't store these questions. I have to do them live. So is it hydrogen or electrification? What do you think? Or near full electrification? So again, yeah, just
Should we
just
say yes for hydrogen and no for
oh, sorry.
electrification?
Yeah, sorry, mate. Yeah, because my apologies, guys. So yeah, yes for hydrogen, no for electrification. My bad there. Thanks, mate. Yeah. Yeah, it'd be good if we could store these questions, Riley?
Yeah, it would. It
Yeah,
would.
yeah. Anyway, so yes for H2 and no as electrification. So anyway, it's coming in. That's good. We're getting some responses coming in, and the yeses way ahead of the no's at the moment. That's really excellent. So can I show that? No. Oh, okay. Is that doesn't come up on the screen, does it, Riley?
It should be visible to everyone. Hang on.
Okay. Yeah.
I think if we leave
Wait
it
there,
like
show. I've got it show responses. I think. I think it should be
uh,
showing now. I can't tell. Obviously, yeah.
I think if it's like that, how it is
Oh,
right
okay.
now, I think they can
Yeah.
see that.
Oh, okay. Yeah. Oh, cool. So anyway, hopefully you can see the responses. The yes is quite large compared to the no's. Again, thank you for that. And I'll have to get faster at typing next time, eh? And again, someone asked before about the source of my material. I've got a reference list at the back, and also where I haven't provided that in a reference list or is also sort of like here, the pictures of the books. Okay, and you'll get that from the slides that Riley will send out, everyone. So what I'll do, I'll have to hide that now so I can click on the next button. Okay, so producing hydrogen, I'm not going to go through this in detail. There are various ways. So steam SMR, that's the blue, you can carbon capture and storage, but if you gasify, for example, coal or use steam methane reforming, it'll be grey or black, so that's not really good. The best one is green. Okay, so you electrolyze water and you're using renewable power. The thing is, to make a kilogram of hydrogen, you need 9 kilograms of water. So just think about that. You actually need to have quite a bit of water, and that's fresh water. I have asked around to some people in industry who know, and there is potential for electrolyzing seawater, which is obviously more available on the planet Earth. I think on planet Earth, around of all the water available, around 2% is only fresh water. A lot of that is ice on Greenland, Antarctica, in the Arctic, Siberia, for example, everyone. So the access to clean water is very low. We could use desalination of seawater, but then we're using power for that to make fresh water. Then we make hydrogen, and then that hydrogen, I use it to burn through a gas turbine. So if you see sort of what I've described now, taking water, electrolyzing it to make hydrogen, that's obviously used energy, which is clean energy, or green energy, which is cool. And then I burn it through a turbine, and that's green energy again. That's cool. But then there's a whole bunch of stuff on the way. And you can even sort of have electrolysis if you've got a nuclear power plant nearby and so on. There are some challenges to hydrogen, and I'll just quickly cover these, everyone. So I'll use my blue highlighter. If you're looking at the heating value, and this is really technical stuff, on a volume basis, it's a third less dense than CH4 methane, so we need larger pipelines. Also, the materials used for pipelines have to be properly designed or selected, should I say, from a materials point of view, because there's a thing called hydrogen embrittlement, and that can be a problem for pipelines. The flame, so hydrogen H2 is actually much faster. So in a turbine, the combustor design has an issue, but safety, and if you know your history, some people refer to the Hindenburg from just before World War II. So if you remember that, it went up in flames, unfortunately, and it wasn't a good day for hydrogen back then. Now, from a safety point of view, hydrogen's hard to see as a flame, and I have an example here on the middle right here, guys. Natural gas, NG, on the left, you can sort of see a purple haze there. Burning hydrogen, I can't really see any type of haze here where I've circled in blue. It actually, because it's a lighter molecule than CH and methane, it'll actually escape through flanges and stuff and seals. It's more flammable, and hazardous ratings can be quite more stringent. Note, if we have a gas turbine that burns basically 100% by volume of hydrogen, it'll see a 99% relative reduction in CO2. That's cool. Yep, that's great. So we can actually reduce our emissions to zero almost. That's fantastic, but we need to get that hydrogen supply, and we need to have a lot of it flowing. Okay. Now, gas turbines for power generation, like I said, I'm really concentrating now on a particular aspect of power generation. Some people think fossil fuels are gone, so gas turbines will be gone in power generation and in aircraft eventually. But at the moment, to 2030, sales are increasing. This is in US dollars, by the way. Not very much, but it's from a magazine called Turbo Machinery, which is really good. But it may plateau off. So again, hydrogen, is it the solution for turbines, for example? Now, aviation. Aviation is an interesting thing. So both Boeing and Boeing's teaming up with NASA for a sort of electric. So this is a concept drawing. It's not a real aircraft, but it's a really good concept drawing of electric motors driving your propellers. And there's 4 on that plane. How you'll get the electric, is there batteries inside, will be an interesting issue. And again, Airbus here on the right, again, has a similar concept. But Airbus has teamed up with an Australian company, Fortescue, and to study hydrogen, so for use on planes. So I've seen a couple of concepts where down the back of the plane, and I'm just sort of circling that, highlighting that in red, will be a little hydrogen station, makes a hydrogen which is supplied to our engines, and the plane can fly. So by 2035, Boeing wants to have an answer to electric propulsion for not only small planes, but large ones too, okay? It'll be interesting how this evolves. Again, there's a word, this is from the website from Boeing, Airbus, not sorry, anyone from Boeing, or sorry to Airbus too, but innovation is there. And obviously sustainability, yeah, everyone talks about that too. Okay, where to next? A bit of a table, just quickly highlight the advantages and disadvantages of various power generation technologies. I've sort of got this from various sources, everyone. In Australia, we got heaps of coal, black and brown, but yuck, very dirty. They've got low operating costs, but now they have high capital costs, okay? No, very high emissions, so not good there. And also a new power plant in Australia, I'll put across because I know no bank will support the funding for a new power plant, for example, guys. All right. And it takes a long time to bring them up to full load from coal. If we do use natural gas for power generation for a gas turbine, I showed a gas turbine before, they actually have basically the highest power density available. So power per weight of machinery to make electricity. They are low construction costs. They're able to burn hydrogen and so on. Nuclear has some issues on safety, and they have a long construction time, and they're very expensive, okay? And there's a severe public backlash possible in a country like Australia. I'll go down the bottom. Renewables now are coming into their own. So, but the biggest thing is the intermittency and availability and reliability concerns, but they have a very low power density. So if I want to generate, say, 100 megawatts, and I'll just write 100 megawatts here, okay, the land area for a gas turbine here would be very small. Okay, so very small area. I'll just draw, but for a solar power plant, I might have a bigger area there, if you see what I mean. So a gas turbine power plant would be small, much smaller than a solar power plant. So that's what I'm talking about in terms of power density. Yeah. Within Australia, our power generation mix, we're looking at doubling renewable generation from now until 2050. So I think a lot of countries are sort of trying to go that way too. Just again, I'm not going to talk about this diagram in big detail, but coal-fired power is down the bottom in the black and brown there. So by say 2040, that's all gone in Australia. So by 2040, we have no black coal or brown coal. Similar for gas, we're going to have gas until 2050, only a very small proportion. And the rest of it will be hydro, large-scale storage, batteries, wind, pumped hydro, and so on. Okay. So again, this is from in Australia, the Energy Market Operator, and there's the reference there for you if you want to look that up. But just note, obviously, coal will be gone, and I'll draw a big cross by sort of 2040. So I've spoken a bit about engineering and stuff, but what about us, the people, the skill sets we need? So as an engineer, it's not just about engineers, okay? Everyone these days, we have connections, yeah? So we crave our connections. Pioneering products, innovation is a multidisciplinary thing. It's not just engineers do that. Mechatronics is more important, but data analysis and sensors. So we're wired with sensors. We crave our connections, but being able to have access to data, real-time data, but processing data. Where I work at our power plant, we have heaps of data available on our machinery, but I need to be able to diagnose that and interpret that for management, for example. Other things, software is expanding all the time, but cyber, so maybe the darker side of things, always be aware of things like cyber, okay? Now, I spoke about everything's involved. Just quickly, this is a thing called the PESTEL model: political, economic, social, technological, environmental, and legal factors. And they impact on an industry and on companies, and they will identify opportunities and threats that we may face within our company, for example, or industry. Okay, in summarizing, everyone, yeah, I like this little cartoon on the left. Okay, to do nothing is not an option. Then we wait and see how things pan out. Now, do we have time? Again, I asked that sort of before. Do we have like 2050? Can we get to net zero by 2050 or by 2040 or so on? Okay, so let's see how that pans out. No, I don't think that's good. We need to be acting now. In Australia, we had a change of government now. So we've had a change of government. So the oil and gas sector could face new pressures under the new government. And here in Australia, coal exit. So coal is actually exiting faster than what they thought. Just to round up, what's possible, there's a suite of technologies that will be required. So we have solar, wind, large-scale battery, pump hydro, run-of-the-river hydro, nuclear power, hydrogen-fueled gas turbines or boilers. Okay, so for making power, electric vehicles, electric aircraft, for example, electric trains, hydrogen-powered ships or ammonia. Ammonia is another one for shipping, so even shipping is going through a transition. So looking at all the available technologies on the supply side. On the demand side, we have more efficient ways. You could actually go off the grid. Your house, a lot of people are thinking of taking their house off the grid. If you have enough solar and wind, little wind turbines that look like a tree or a fan, you make your own power, store it in your battery at home, you go off the grid. What happens if I don't have wind or sun for a few days? I still have the connection to the grid. And that way, if I need to go off the grid, I can. Also, there's other things now. I'm not sure if you've heard of these. Mobility as a service. I don't own a car anymore. I'll get a car when I need, and I'll just use the app for that. Energy as a service. I'll actually have an app that will tell me to optimize my energy use, and in general, transport as a service, which is sort of linked to the mobility one. So there's all these sort of concepts coming out. Many thanks for the opportunity. Please send an email to that webinars at EIT, and that comes out in the presentation. And just to round off, there's the whole, okay, so you got my reference list on one page there, Riley, that's cool. Again, please get in touch with that, and Riley can forward on if you have a specific question. And that's about it. Thank you very much for listening. Riley, you can take over again. Thanks, mate.
Thanks, Lucas. Really appreciate that. And I'm sure everyone really found that an insightful presentation. And I think this topic is not only relevant to engineers but to everyone, you know, and that's why it's so relatable. So, and before we wrap up, everyone, I'd just like to just mention that we have more technical webinars you can register for on our website. So these are all free, just like this one. So they're free 1 hour technical engineering sessions. So you can see we've got one next week on low voltage protection devices. We have our civil engineering course coordinator, EIT, presenting current trends on concrete as construction material to capture CO2. You know, Lucas was mentioning that before about concrete capture. Carbon capture.
Carbon capture storage, yes.
Yeah, and we've got augmented virtuality to Industry 4 and beyond from our industrial automation course coordinator, and then we also have another construction one. So we're focusing on a lot on sustainability lately, which seems to be the general trend in a lot of engineering disciplines. And yeah, you can register for all of them on our events page. So just go to our events page if you want to register for any of those, and we regularly update that page. And as I mentioned at the start of the webinar, we have a range of courses, and this kind of gives you a brief overview of all of our course types. So we have a lot of courses. I wouldn't be able to list them all in a few slides, but this gives you just a general idea. So our short courses, our diplomas and advanced diplomas, they all have different intakes. Each course has different intakes throughout the year. They don't follow a certain format. So every course is different there. And then for our undergraduate certificates, bachelor's degrees, and our Doctor of Engineering, all our online versions, they start on the 25th of July. Our graduate certificates and Master of Engineering degrees online as well. They start on the 27th of June. And actually, if you did want to apply for one of our graduate certificates or master's degrees, the application deadline is on Monday next week, so that's pretty close. And then our on-campus courses. So we do offer on-campus courses in Australia. We have a campus in Perth, Western Australia, and then we also have a campus in Melbourne, Victoria. So we have on-campus courses starting on the 1st of August. However, I will mention that if you would like to study a course at EIT, or if you're browsing, just go to our schedule page. I really like the schedule page because it shows you all of our courses sorted by date, and it shows all the intakes that we have. So it just gives you a very detailed, you know, one line for each course, and it'll give you a list of all of our courses and intakes. Now, as promised, so we do provide a certificate of attendance for our technical webinars. I see a few people putting their email address in the chat box. You do not need to put your email address in the chat box. It's probably not good to provide your personal email address in a public domain anyway. However, yeah, so there's no need to provide your email address. If you'd like a certificate of attendance, you need to fill out the form provided here. So if you either enter that that link in your browser in a new tab, you can do that. That in there. Or if you've got your smartphone, just if you've got your smartphone, just scan the QR code. So I've just put the link in the chat box there. It'll take you to a short form you need to fill out. And once you've filled out that form, I'll send I'll send all the certificates out likely tomorrow. And yeah, you can scan that QR code as well. It's up to you. You can click the link in the chat box, or you can scan the QR code. But it doesn't matter either way. But yeah, you don't need to provide your email address, because I won't provide a certificate to you if you don't fill out the form. Okay, so that's I'll just leave that slide up for a couple more seconds. And then basically that's the end of the presentation. So again, thank you, Lucas, and thanks to everyone that's attended the webinar today. But we will stick around for some questions. I'll just leave this slide up. We have a Q&A slide, but I like to leave this last slide up because it's just got all of our contact details. So if you need to go, thank you very much. Otherwise, please.
I could do another
know.
10 minutes, mate.
Yeah, great. Thanks, Lucas. Yep. If anyone has any questions,
quarter past
please.
the hour. Yeah, speak
Great.
up, please.
No worries.
Maybe.
Thanks for all the comments, guys. We really appreciate it. If you've got any technical questions for Lucas, or you have general questions about EIT or our courses, please let me know. Thanks, guys. It's pretty quiet so far, but yeah, we might get some questions. Maybe some people are still typing, but if not,
okay, mate. Yeah.
If not, then we can wrap it up in a couple of minutes, but we'll just wait a little bit longer.
Yeah, sure. Yeah, sure.
There's a question there, Lucas.
What's that, mate?
Someone's just commented, can a nation produce energy using solar only? Is that a possibility?
Yeah, yeah, it is. It's a possibility. There was something in the late 2000s. Somebody was looking at a project, Northern Africa, and they had, I think it was about 1,000 square kilometre solar grid, and they would then supply Europe with all that power. So even in Australia we can, but I mean then it'll sort of only when the sun's shining. And if we can store it, that's fine. But if we can't store it, that's the problem. But you can, if as long as you've got a sunny days. So there's an issue there again. Now someone's asking about EV charging. So future is in Australia. There's a lot of EV charging stations now, and on the highways especially, we can get. I think the best viable Tesla is around 500 kilometers, and you can sort of drive a fair distance, but you still need to charge for half an hour. So they're establishing what they call EV superhighways in Australia in most states. So yeah, it's and the actual cost of the electric vehicles start coming down. In Australia, we don't have any rebates, so it's expensive. But as they keep making more and more of these, it'll be like the mobile phone, computers, and everything. The cost will come down over time as you get economies of scale.
Yeah. There's a question here.
Yeah, what's that, mate?
Someone's asked, does EIT offer to international applicants? Yes. So
Yep.
if you're an international student, depending on what kind of course you're going for, so we have students from over 150 different countries around the world, which is pretty amazing. But most of our courses, we deliver online. So as I mentioned, that range of courses, all of our courses are delivered online. However, we provide the option that our bachelor's, master's, and doctorate of engineering can also be studied on campus in Australia. But we're open to any applicants. But you got to also keep in mind the entry requirements for our courses, and you can speak to our course advisors regarding that. And obviously, if you submit an application, either our learning support team or our admissions team will get in touch with you.
Oh, yeah, I saw a couple of other ones up the top about what should they study. I reckon power electronics. So, power electronics and electrification would be a good one. I still know about your thermodynamics, but electrification technologies. There was another one about can solar actually provide solar can, but you need battery backup or some other type of backup for solar. There is some research I saw. I'm not sure if it's a bit out there that even in the moon you can get sort of pseudo solar from the moon. I thought that's interesting. So companies are looking at various ways to get solar energy. There was another one there. I can see about grid stability. Yes, that's very important because at the moment grid stability is, but a lot of rotating equipment will be used as a synchronous condenser, as they're called. So again, that's more from an electrical point of view. Another one's about solar plants. Yeah, they could. I mean, national probably, if you're looking at best efficiency, probably privatisation is a better way to go, because a lot of people think that if you nationalise an industry or a sector, it becomes inefficient. So, I mean, having studied economics, privatisation is better, but as long as there's effective competition, we should be able to get a good deal for price and quality of the panels too. So it's not just about the price of something, it's also the quality that provides.
I have a
Another one.
question
Oh,
from
sorry, mate.
Vanya.
Go for it. Go,
So
sorry, mate. Yep.
it's all right. The
Yep.
doctorate and master's programs. So needing to enroll by Monday. So we have graduate and graduate certificates and master's degrees. So both postgraduate qualifications. Not the doctorate though. So the graduate certificates and master's programs. The application deadline for those for the next intake, for our online intake, is this Monday. And what that means is that you have to start your application before Monday. So if you have your application started, before Monday, and it's still you're kind of you're midway through, you saved your application, that's fine, but do not wait till Monday to start your application. They allow another 2 weeks for people with pending applications to finalize their applications by the following 2 weeks. But it's best to start your application as soon as possible, and then you can finalize it in the next 2 weeks, hopefully, if you're wanting to enroll for our master's or graduate certificate programs. Sorry, Lucas, you keep going.
Yeah. No, that's right. I think that more of them now is just about the certificates and stuff. Wait, there's one there. You didn't talk about standalone systems. Oh, yeah, I know. It's so much I could have covered. I sort of spoke about, you can have, I know they're talking about the decentralized or point of consumption. I see it as a decentralized, distributed microgrids and stuff. You can have those too, and they sort of like a point of consumption energy source, energy supply, and that can be located at your house or at your industrial site or a building, for example. Yes.
I think I have a couple of questions to answer. So I saw one about student visas. Yep, so if you're looking at studying on campus with us, please get in touch with one of our course advisors and they'll be able to assist you there. But we do recommend international students to apply through one of our registered education agents if you're wanting to study on campus. Scholarship options available for international students. Yep, we have a range of scholarships, partial scholarships for international students. You can go to our scholarships page on our website and have a look at those future student scholarships. We have scholarships for different programs. There's different eligibility requirements. Have a look, and you can also speak to one of our course advisors about that. And then I saw another one, Vanya. Yes, so we had Commonwealth supported places for some of our undergraduate certificates and graduate certificate programs. Unfortunately, those have ended. We don't have any more Commonwealth supported places anymore. We don't know when we may or may not get some in the future. It is entirely up to the government. However, yeah, so we're back to normal. We don't have any Commonwealth supported places anymore. However, you can look at our scholarships and you can apply for our scholarships because we do have scholarships available for those programs as well. So and we do have payment options that you can also discuss. Are there any other questions you wanted to answer, Lucas, or do you need to head off now?
Yeah, I'll head off. I'll just quick couple of ones here about the transition. Someone's asking about other countries. Like I mentioned, the just energy transition. My hope is that it helps everyone. So, I mean, I don't have a magic wand. No one does, but it hopefully does help everyone. And the cost of these, again, there's a whole bunch of factors, but one of them being the cost of these technologies and how easy it is to get them to a place, and that should help. Another one is waste. They're trying to reduce the amount of waste is actually beneficial because again we get more efficient. And again, another comment there about the rare earth. Yeah, rare earth metals definitely. The demand for that is increasing, and yeah, that's about it. So I have to depart. Sorry, Riley, but yeah, thanks very much, everyone. It was really great.
No worries, Lucas.
Interconnected microgrids, probably Europe. There's a question just come in. I'm not sure if Australia doesn't sort of do that, but maybe in Europe they would do that. Yeah, but I'll have to leave now. But thank you very much again, and thank you everyone, and all the best. Hopefully, some might do a course at EIT.
Great. Thanks very much, Lucas. And
Thank you.
yeah, we'll wrap up the webinar. So thank you very much, everyone. And we hope to see you again soon. Have a great day wherever you are.
Okay, thanks, Riley. Thanks, everyone. Bye. Cheers.